Right, hi everybody. Here is question 109 from chapter 9. This question gives us a mass percent composition and is asking for a Lewis structure proposal. It's only made of carbon and hydrogen, but even just for a carbohydrate, or a hydrocarbon, I should say. That's a pretty cool kind of question. All right, so mass percent means that in 100 grams of this thing, whatever it may be, we're going to have whatever the percentages of hydrogen in grams. This is 7.743 grams of hydrogen. And we're going to have, in addition to that, whatever the difference is in carbon, which is 92.257. 7 grams of carbon. Okay, so moles of both of these things, right? We're on the hunt for a empirical formula of sorts, because we're not given a molar mass in this case. So this is going to be all that we can get. All right, so moles of hydrogen, right? The mass atop the formula weight, right? 1.008 U gives us 7.682 moles of hydrogen. Moles of carbon equals 92.257 grams over 12.01 grams per mole equals 7.682. So, for an empirical formula, we have about the easiest one in the book for two species, which is a 1-to-1 ratio. Now, if you're thinking in terms of how am I going to satisfy electron obligations in this case? I mean, methane's got like 4 things. You're going to have to mix in double and possibly triple bonds into this thing. But you have a couple options that are possible. Actually, it turned out that the solution that I went for wasn't the one that was in the textbook, but the textbook one was simpler. So I'm going to include both. The textbook suggested acetylene, which is a triple bond between 2 carbons, all right, and then a hydrogen attached to either side, and that satisfies this empirical formula here. The one that I had thought of was an aromatic ring. And in this case, it wouldn't matter how many carbons you had, or how many members you had on the ring, I should say. 4, 5, 6. But I thought of benzene. So these rings alternate double and single bonds, right? If you're doing some organic chemistry in the future, typically these things are abbreviated in the textbooks like that, right? This to show the resonant distribution of the electron cloud, right? And that is shown in the Lewis structure with this alternating double and single bonds, right? Great electron conductors, right? I'm sure you guys have seen the chlorophyll molecule. Watch how the energy from the photon gets transferred along this, sort of like a ripple like that. Very cool, a very cool thing to think about. But this works out too in the same way that you're going to have a 1-to-1 CH ratio, right? So I thought immediately of this, but the textbook surprised me with another one. So that's also a good take home. There is more than one way to skin the cat.